Now, in this lecture, we'll find out the radius of the small circle. In the drawing, we have a circle that is inscribed by a semicircle. We know that side CD equals to 4 units, side BD equals to 4 units, angle CDB equals to 90 degrees, and we want to find out the radius of this small circle. So first of all, we will make a construction. We will complete the semicircle to a circle. So we completed the semicircle to a circle. In the next step, we will extend line segment CD until it touches the circle. And we define the touching point of the extended line segment CD and the circle as point E. So actually, we extended the straight line CD by a straight line and created the line segment CE. When you extend a straight line by a straight line, the result must be a straight line. So the result of the extension of CD must be a straight line, that is to say CE is a straight line. Okay, so you can write down that line segment CE is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line CE at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at point D? We have 90 degrees and also angle EDB. So 90 degrees plus the size of angle EDB. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? So here we will subtract 90 degrees from this equation, and we will get that angle EDB equals to 180 degrees minus 90 degrees. That is to say, angle EDB equals to 90 degrees. So this angle is a right angle, it is equal to 90 degrees. And actually we found out, we know that angle CDB equals to 90 degrees and angle EDB also equals to 90 degrees. Therefore, DE is the mirror image of CD. Okay? First of all, when we created the circle from the semicircle, we created another semicircle. This semicircle is a mirror image of this semicircle. And then, when we drew this, when we extended the straight line CD and created the line segment DE, we actually created DE is the mirror image of CD. And because of the fact that DE is a mirror image of CD, it means that DE equals to CD in its length. DE equals to CD by symmetry. Like if you look in a mirror, you see yourself exactly in the same dimensions that you are in reality, but in the opposite direction. Okay. Here it is also true to say that DE is in the opposite direction of CD, but it is equal in its length to CD. So that is to say D equals to CD. Okay? But according to what is given us in the question, CD equals to 3 units. Okay, CD equals to 3 units. And from this equation, D equals to CD equals to 3 units, we will derive that DE is also equals to 3 units. Okay, so we can write here that DE equals to 3 units. In the next step, I will present to you a new rule that is actually rule number 1. According to rule number 1, if chord AB intersects with chord CD at point O, if chord AB intersects with chord CD at point O, that is to say, the intersection point between chord AB and chord CD is happening at point O. Then AO times OB equals to CO times OD. Okay. I will read rule number 1 again. According to rule number 1, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. So in this drawing, we have here chord AB. This is chord AB. That intersects with chord CD. This is chord CD. And the intersection point is occurring at point O. Point O is the intersection point of point AB, of chord AB with chord CD. So according to rule number 1, if this is the data that has been given to us, then according to rule number 1, AO times OB equals to CO times OD. Okay. AO times OB equals to CO times OD. We actually can implement rule number 1 in our drawing. because in our drawing we have this the big circle. Inside the big circle we have chord AB that intersects with chord CE at point D. Point D is the intersection point of chord AB with chord CE. So write it down that in our drawing we have chord AB intersects with chord CD at point D. I repeat again, in our drawing we have chord AB intersects with chord CD at point D. Point D is the intersection point of chord AB with chord, it's actually chord CE. Okay, chord CE. Again, chord AB intersects with chord CE at point D. Therefore, according to rule number 1, we get that AD times DB equals to CD times times DE. Again, AD times DB equals to CE times DE. I write it down here. We get that AD is actually AB times BC and AD times DB equals to CD times DE. I repeat again. According to rule number 1, AD times DB equals to CD times DE. Here AD is the missing line segment, so we leave it as it is, times DB. DB equals to 4 units according to what is given us in the question, so we will substitute DB by 4, and it is equal to CD. CD equals to 3 units according to what is given us in the question, so we substitute CD by 3 times DE. DE is also equal to 3 units according to what we have already found out, so we substitute DE by 3. So in conclusion, we found out that AD times 4 equals to 3 times 3. 3 times 3 is 9, so we write down that 9 equals to 4 times AD. Here we will divide this equation by 4, and we get that according to this equation, AD equals to 9 over 4. Okay. If the missing line segment AD is equals to 9 over 4 units, actually we know that AB is the diameter of this circle and also the diameter of the semicircles. And we also know that the diameter is twice as long as the radius. So if we divide the diameter AB by 2, we will get the radius. We define the radius of the big circle and the radius of the semicircle as capital R, and we will get that capital R equals to AB over 2. Okay? And from the drawing we can see that AB, the diameter AB equals to AD plus DB. So we substitute AB by AD plus DB. Over 2. We have already found out that AD equals to 9 over 4. We substitute AD by 9 over 4. And we already know that dB equals to 4 units according to what is given us the question. So we substitute dB by 4, all divided by 2. Here we will multiply 4 by 4 and also divide it by 4 in order to have a common factor with 9 over 4. So here we get that 9 plus 4 times 4 is 16 over 4 over 2. 9 plus 16 is 25, so it is 25 over 4 over 2. We will move to the denominator, and we get that 25 over 4 times 2 equals to the radius of the big circle. 25 over 4 times 2 is 8. So, in conclusion, we found out that the radius of the big circle that is defined as capital R, it is equal to 25 over 8 units. Okay. In the next step, we will define the center of the big circle as point P, and we will define the center of the small circle as point Q. And then we will find out the length of line segment DP. The small line segment DP. So DP, from the drawing, it is very easy to see that DP equals to DB minus PB. I repeat again, DP equals to DB minus PB. So DP equals to DB. DB equals to 4 units according to what is given us the question, so we substitute DB by 4 minus PB. What is the definition of line segment PB? P is the center of the big circle, and B is the point on the big circle itself. That is to say, PB is the radius of the big circle that is equal to capital R. Okay, so actually in conclusion we found out that the P equals to 4 minus capital R, that is R is the radius of the big circle, but we have already found out that capital R This is the radius of the big circle. Here it is equal to 25 over 8. So we substitute capital R by 25 over 8. We'll do it now. We will get that dp equals to 4 minus the radius of the big circle, that is 25 over 8. So here we will multiply 4 by 8 and then we divide it by 8 in order to overcome total with 25 over 8. Okay, so we will get that 4 times 8 is 32 minus 25 over 8. So here 32 minus 25 is 7 eighths. So the conclusion found out that dp equals to 7 eighths. So we can write here that dp equals to 7 eighths in the next step. We will define the point of tendency of tangent dB with this small circle as point M. Again, point M is the point of tendency of tangent dB with this small circle. And then we will define the point of tendency of tangent CD with this small circle as point O. And we will join together points Q and O by a straight line. So here, what is the definition of line segment QO? Line segment QO starts from the center of the small circle, that is to say from point Q, and ends at point O, that is a point on the small circle itself. This is exactly the definition of a radius. So QO is the radius of the small circle. We define the radius of the small circle as small r. So r is the radius of the small circle. Here. And we have here the radius QO of the small circle. It is drawn to the point of tendency. That is to say, it is drawn to point O, that is the point of tendency of tangent CD with this small circle. And now we have a radius that is drawn to the point of tendency. Then the tangent CD will be perpendicular to the radius DQ. Then the tangent CD will be perpendicular to the radius QO. So if CD is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, from point, we join points Q and M together by a straight line. So here, QM is the radius of the small circle for the same reasons that QO is the radius of the small circle. Here, point Q starts, the line segment QM starts from point Q, that is the center of the small circle, and point M is the point of the small circle itself, and this is exactly the definition of a radius. That is to say, QM is the radius of the small circle that is equal to small r. So here we have the radius QM. It is drawn to the point of tendency. That is to say, QM is drawn to point M, that is the point of tendency of tangent dB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent dB will be perpendicular to the radius MQ. Again, the tangent dB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. In the next step, we will focus on quadrilateral OQDM. In quadrilateral OQDM, we have 1, 2, 3 right angles. So write it down. In quadrilateral OQDM, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle OQM, in total it must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. I'll repeat again. The sum of 3 angles is 270 degrees plus the size of the fourth angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We'll subtract 270 degrees from this equation. And we will get that the missing angle OQM is equal to 360 degrees minus 270 degrees, it is 90 degrees. So it is actually a right angle. So we found out that this angle is a right angle, it is equal to 90 degrees. So actually in quadrilateral OQDM we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral OQDM as a rectangle. I write it down. Quadrilateral OQDM is a rectangle. Okay, now repeat again. Quadrilateral OQDM is a rectangle because of the fact that it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of a rectangle OQDM, they are equal to each other. It means that OQ equals to DM. OQ equals to DM according to the rule that the opposite sides of a rectangle are equal to each other. But we have already found out that OQ equals to small r, it is the radius of the small circle. And from this equation r equals to OQ equals to dm, we will derive that dm is also equals to r. dm equals to r. Okay, here we can write down that dm is equal to r. Okay, in the next step we'll find out the length of line segment PM. What is the length of line segment PM? From the drawing it is very easy to see that PM equals to dm minus dp. dm minus dp equals to PM. Okay. I'll repeat again, PM equals to dm minus dp according to the drawing. So PM equals to dm equals to r, small r according to what we have already found out, so dm equals to small r minus dp. We have already found out that dp equals to 7/8. So in conclusion, we actually found out that PM equals to R minus 7/8. Okay. So here we define the touching point of the big circle with the small circle is point S. Point S is the point of tendency of those two circles, the big circle and the small circle. And point S is also the launch point of the two circles. It is actually internal launch point. Why in this drawing we have an internal launch point? Because of the fact that the small circle is located inside the big circle, and the two circles are touching each other internally. Therefore, in this drawing we have an internal launch point. Okay. repeat again that in this drawing we have an internal launch point between those two circles, the big circle and the small circle. Why? Because they are touching each other internally at point S. Point S is the launch point, and the reason that this is an internal launch point is because of the fact that the small circle is located inside the big circle. Okay? So in the next step, I will present to you a new rule that is actually rule number 2. According to rule number 2, if two circles have an internal launch between them, then the straight line that connects their centers passes through the launch point. So I'll read rule number 2 again. According to rule number 2, if two circles have an internal launch between them, then the straight line that connects their centers passes through the launch points. So in our drawing, we have an internal launch, as I've already explained. We have here an internal launch at point S. Point S is the point where the two circles are touching each other internally. That is to say, point S is defined as a launch point. So here in this drawing we have an internal launch between the small circle and the big circle. Therefore, according to rule number 2, the straight line that connects between their centers, point P is the center of the big circle. Point Q is the center of the small circle. And the straight line that connects their centers together is the straight line or line segment QP. And this line segment QP passes through the launch point that is actually point S. So PQS, here, PQS is one straight line. The straight line PQ passes through the launch point that is point S, that is to say points P, Q and S, they are all located on the same straight line. We draw from rule number 2, that points P, Q, and S they are all located on the same straight line. Or in other words, we can also say that if line segment PQS is a straight line. Line segment PQS, this line segment in the red color, is a straight line. PQS is a straight line. All according to rule number 2. All the things that we concluded according to rule number 2, of course. And what is the definition of line segment QS? Q is the center of the small circle. S is a point on the small circle itself. This is exactly the definition of a radius. That is to say, QS is the radius of the small circle that is equal to small r. And what is the definition of line segment PS? This line segment in the red color, point P is the center of the big circle. Point S is a point on the big circle itself. This is exactly the definition of a radius. That is to say, PS is the radius of the big circle that is equal to capital R. But we have already found out that capital R equals to 25 over 8. So in conclusion, we found out that PS equals to capital R, that is equal to 25 over 8 units. And what is the length of line segment PQ? The length of line segment PQ, from the drawing, it is very easy to see that the length of line segment PQ is equal to PS minus QS. PS minus QS. Here, PS minus QS equals to PS minus QS equals to PQ. I'll repeat again. From the drawing, it is very easy to see that PQ equals to PS minus QS. So PQ equals to PS equals to capital R, according to what we have already found out. PS equals to capital R, so we substitute PS by capital R minus QS. We have already found out that QS, this line segment, equals to small r. So in conclusion, we found out that PQ equals to capital R minus small r. Okay? But we have already found out that capital R equals to 25 over 8, so we substitute capital R by 25 over 8. And in conclusion, we actually found out that PQ equals to capital R, that is 25 over 8 minus small r. Okay? So we can write here that PQ equals to PQ equals to 25 over 8 minus small r. Okay? In the next step, I will copy the right green triangle QPM in a new page, and we will implement the Pythagoras theorem on this green right triangle QPM. Okay? This is the right triangle QPM that I copied from the original drawing. And here we have already found out that the hypotenuse PQ, which is equal to 25 over 8 one small r. We have already found out that the side PM, it is equal to r small r minus 7/8. And we've already found out that QM equals to small r, that is actually the radius of the small circle. I'll repeat again that we will actually implement the Pythagoras theorem on this right triangle, triangle QPM. So by PT is the abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, we get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is QP, the square of the hypotenuse is QP square, and QP square will be equal to the sum of the squares of the perpendiculars. This is to say it will be equal to QM square plus PM square. So I write it down according to the Pythagoras theorem. This will be equation number 1. The square of the hypotenuse is PQ square. It must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to QM square plus PM square. We have already found out that PQ equals to 25 over 8 minus small r. Therefore, PQ square is 25 over 8 minus small r square. QM equals to small r, so QM square will be equal to small r square plus PM. PM equals to r minus 7/8, so PM square will be equal to r minus 7/8 square. So here we will open the brackets on both sides of the equation number 1, and we get that 25 over 8 minus r square equals to, according to the algebraic identity, that a minus b square equals to a square plus b square minus 2 times ab. So here 25 over 8 minus r square will be equal to 25 over 8 square, that is 25 square is 225 over 8 square is 64 minus, plus r square minus 2 times 25 over 8 times r, and it is equal to r square plus r minus 7/8 square, that is actually equals to r square plus 7/8 square, with 7 squared that is 49 over 8 squared that is 64, minus 2 times small r times 7/8. So here we have r square on both sides of the equation, so r square will get cancelled. And what is left from equation number 1 after we cancel r square? What is left is that in this side we're left with 625 over 64. And here we have the expression minus 2 times 25r over 8. We divide both the numerator and the denominator of this expression by 2. And we get that minus 2 over 2 is minus 1, so 2 will get cancelled. In the denominator In the numerator we left only with minus 25r. In the denominator we have 8 that is divided by 2 equals to 4. So in conclusion, this expression equals to minus 25r over 4. Okay? And in the other side of equation number 1 we have r squared plus 49 over 64. Here we have the expression minus 2r times 7 over 8. We divide both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, so minus 2 will get cancelled. When you left only in the numerator with minus 7r. In the denominator we have 8 that is divided by 2, it is 4. So in conclusion, the expression minus 2r times 7 over 8 equals to minus 7 or r over 4. Okay, so here we will multiply equation number 1 by 64, and we will get that according to equation number 1, 625 times 64 over 64 is 625. Here we have to multiply minus 25r over 4 by 64. So it is minus 64 over 4, that is minus 16, times 25r. So in total this expression minus 25r over 4 after we multiply it by 64, it is equal to 16 times minus 16 times 25r. Here r squared times 64 is 64r squared. Here we have 49 times 64 over 64 equals to 49. Here we have to multiply minus 7r over 4 by 64. So it is actually equals to minus 64 over 4, that is minus 16 times 7r. So in conclusion, this expression minus 7r over 4 after we multiply it by 64, it is equal to minus 16 times 7r. Okay, so actually according to equation number 1, we actually found out that $625. Here we have minus 16 times 25r equals to minus 400r. That is equal to 64r squared plus 49 minus 16 times 7r equals to minus 112r. So in conclusion, I found out that according to equation number 1, 625 minus 100r equals to 64r squared plus 45 minus 112r. Here we will add 400r to this equation number 1. So here we have 625. 400r minus 400r is 0, so in this side of the equation we left only with 625. This is equal to 64r squared plus 49. Here we have 400r minus 112r equals to plus 288r. Okay, so here we will subtract 625 from this equation number 1, and we will get that according to equation number 1, 625 minus 625 is 0, and it is equal to 64r squared and plus 288 R. Here we have 49 minus 625 equals to 576. So here we will divide this equation number 1 by 32, and you will get that according to equation number 1, (64/32) is 2, so this expression in total equals to 2r squared plus 288r/32 equals to 9r minus 576/32 equals to minus 18. Here 0/32 equals to 0. So in conclusion, we got the quadratic equation, the 2r squared plus 9r minus 18 equals to 0. The coefficient a in this quadratic equation equals to 2. The coefficient b equals to 9. And the coefficient c equals to minus 18. And the variable that we are looking for in this quadratic equation is r, so x equals to r. And the general formula for solving out a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In the general quadratic equation, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, 2r squared plus 9r minus 18 equals to 0. The variable that we are looking for is r, so x equals to r, so we substitute x by r, and we get that r equals to minus b, b equals to 9, so minus b is minus 9, plus minus square root of b squared. B is 9, so b squared is 9 squared, that is 81, minus 4 times a is 2, times c is minus 18. All divided by 2a. A is 2, so 2a is 2 times 2, that is 4. So in conclusion, we found out that r equals to minus 9 plus minus square root of, here we have minus 4 times 2 is minus 8, minus 8 times minus 18 is plus 144. So inside the root we have left only with 81 plus 144, all divided by 4. So we actually found out that r, the radius of the small circle, it is equal to minus 2 plus minus the root of 81 plus 144 is 225 divided by 4. So we got actually that r equals to minus 9 plus minus the square root of 225 is 15 over 4. So here we have two solutions that are possible for r. This is the radius of the small circle. The first solution for r is that r equals to minus 9 minus 15 over 2. Minus 9 minus 15 is minus 24, and minus 20, it is over 4. It is over 4 over 4. 4a is 4, so it is over 4. So, and minus 24 over 4 is minus 6. So we found out that r equals to minus 6, that is a negative number. But because of the fact that small r is defined as the length of the small circle, the length of the radius of the small circle. Here it is the length of the radius of the small circle. So r is a length, it must be a positive number. R is a length, and as a length, it must be a positive number. Therefore, it can never be equal to minus 6, that is a negative number. So we will cancel this solution and we left only with the second solution, that r equals to minus 9 plus 15 over 4. Minus 9 plus 15 is 6, and r equals to 6 over 4. We'll divide both the numerator and the denominator of 6 over 4 by 2. 6 over 2 is 3, and 4 over 2 is 2. So in conclusion, we found out that r, the radius of the small circle, it is equal to either 3 halves, of units, or in terms of numbers, it is equal to 1.5 units. Okay? I'll repeat again. The length of the radius of the small circle here, and it is equal to either 3 half units, or in terms of numbers, it is equal to 1.5 units. So we finished to answer on the question. In the next step, I will summarize the lecture. Okay, so actually, we wanted to find out the radius of this small circle that is inscribed by a semicircle. Side CD equals to 3 units, side DB equals to 4 units, and angle CDB equals to 90 degrees. And we want to find out the radius of this small circle. So in order to find out the radius of the small circle, actually we did a construction. We completed the semicircle to a circle. By completing the semicircle to a circle, we actually created the second semicircle that is the mirror image of the original semicircle. I repeat again, the second semicircle that we created by completing the semicircle to a circle, it is the mirror image of the original semicircle. Okay? And then I'll repeat again here. Here, the second semicircle that we created by completing the semicircle to a circle, this semicircle is the mirror image of this semicircle, that is the original semicircle. And then we extended the straight line CD by a straight line until it touches the circle at point E. Point E is the touching point of the extended line segment CD in the circle. And actually, when you extend a straight line by straight line, the result must be a straight line. So when we extended the straight line CD by straight line, the result is CE, that it must be a straight line. So here, line segment CE is a straight line. Okay? And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line CE, at this point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? We have here 90 degrees and angle EDB. In total, the sum of those two angles must be equal to 180 degrees. Here, 90 degrees plus angle EDB must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that the missing angle EDB equals to 180 degrees minus 90 degrees, it is 90 degrees. So G is angle EDB equals to 90 degrees. So actually we know that angle CDB equals to 90 degrees, it is given as the question, and this angle EDB also equals to 90 degrees. Therefore, when we extended the straight line CD that is perpendicular to AB, we got the straight line ED that is also perpendicular to AB. That is to say, line segment DE is a mirror image of line segment CD. Again, DE is the mirror image of CD. And when you have the mirror image of something, it is always the same length of the image itself. When you look at yourself in a mirror, you see yourself exactly with the same dimensions as you are in reality, but in the opposite direction. And the same thing is true also to those two line segments. ED is the mirror image of CD, therefore ED equals to CD. They are equal to each other in their lengths, but they are in the opposite sides. And the point that is common to them is point D. So one is the opposite side of the other. So in conclusion, we actually found out that DE equals to CD because of the fact that DE is the mirror image of CD. They are equal to each other in their length, so they are equal to each other by symmetry. Okay? But it is given as the question that CD equals to 3 units. So from this equation, D equals to CD equals to 3, we will derive that DE is also equals to 3 units. Okay? DE is also equals to 3 units. Then I presented to you rule number 1. According to rule number 1, if chord AB intersects with chord CD at point O, if chord AB intersects with chord CD at point O. Point O is the intersection point of chord AB with chord CD. Then according to rule number 1, we will get that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We actually can implement rule number 1 in our drawing. Why? Because in our drawing, we have chord A. We have this circle, and inside this circle we have chord AB that intersects with chord CE at point D. Again, chord AB intersects with chord CE at point D. Point D is the intersection point of chord AB with chord CE. Therefore, according to rule number 1, we will get that AD times DB equals to CD times DE. Again, AD times DE equals to CD times DE. Okay? Repeat again, chord AB intersects with chord CE at point D. Therefore, according to rule number 1, AD times DB equals to CD times DE. AD is the missing line segment, so we leave it as it is. DB equals to 4 units according to what is given us in the question. CD is also equals to 3 units according to what is given us in the question. And we have already found out that DE equals to 3 units. So in conclusion, we found out that AD times 4 equals to 3 times 3, that is 9, or 4 times AD equals to 9. We divided this equation by 4, we found out that the missing line segment AD equals to 9 over 4. Okay, this is the missing line segment AD equals to 9 over 4. And then we know that AB is the diameter of the circle and also the diameter of the semicircles. And the diameter of any circle or semicircle is twice as long as the radius. Therefore, the radius, if we define the radius of this circle and the semicircles as capital R, the circle and the semicircles have the same radius. Therefore, we will define the radius of the semicircle and the circles as capital R. And capital R will be equal to the diameter that is AB over 2. From the drawing, you can see that AB equals to AD plus DB. Here AB equals to AD plus DB. We have already found out that AD equals to 9 over 4 units and DB equals to 4 units. It is given us the question. All divided by 2. Here we multiplied 4 by 4 and then we divided by 4 in order to have a common factor with 9 over 4. 9, so 9 plus 4 times 4 is 16, divided by 4 and then divided by 2. 9 plus 16 is 25. 25 over 4 divided by 2. We moved 2 to the denominator. We got the 25 over 4 times 2. 4 times 2 is 8, so in conclusion we found out that the radius of the big circle, that is also the radius of the semicircles, it is equal to 25 over 8 units. Okay? Then we define the center of the big circle as point P. We define the center of this small circle as point Q. And then we calculated the length of the small line segment DP. From the drawing it is very easy to see that the length of this small short line segment DP, it is equal to dB minus PB. Again, dB minus PB equals to dP. Repeat again, dP equals to dB minus PB. dB equals to 4 units according to what is given as the question. And what is the definition of line segment PB? P is the center of the big circle. B is the point of the on the big circle itself. Okay, so this is exactly the definition of a radius. That is to say, PB is the radius of the big circle that is equal to capital R. So we can substitute PB by capital R, and we got actually the dP equals to 4 minus capital R. But we have already found out that capital R, the radius of the big circle, it is equal to 25 over 8, so we can substitute capital R by 25 over 8. We did it, and we got that dP equals to 4 minus 25 over 8. Here we multiplied 4 by 8, and then we divide it by 8 in order to have a common factor with 25 over 8. So here 4 times 8 is 32. In the numerator we have 32 minus 25, that is 7. In the denominator we have 8. So in conclusion we found out that the short line segment dP equals to 7/8 units. Okay? This short line segment equals to dP equals to 7/8. Okay? Then we defined here we defined the point of tendency of tangent CD. Here we define the point of tendency of tangent CD with this small circle as point O, and we also define the point of tendency of tangent DB with this small circle as point M. And then from point Q we join points Q and O together by a straight line. What is the definition of line segment QO? Q is the center of the small circle. O is the point of the small circle itself. This is exactly the definition of a radius. So QO is the radius of the small circle that is equal to small r according to our definition. And here we have the radius small r that is equal to QO. It is drawn to the point of tendency. That is to say, it is drawn to point O, that is the point of tendency of tangent CD with this small circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent CD will be perpendicular to the radius QO. CD is perpendicular to OQ. So if CD is perpendicular to OQ, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we connected points Q and M together by a straight line. The definition of QM is the radius of the small circle. Why? Because it starts from the center of the small circle and then the point M, that is the point on the small circle itself. This is exactly the definition of a radius. So QM equals to small r, that is the radius of the small circle, and here we have the radius QM. It is drawn to the point of tendency, that is to say, it is drawn to point M, that is the point of tendency of tangent DB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent DB will be perpendicular to the radius MQ. So DB is perpendicular to MQ, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? Then we focused on quadrilateral OQDM. In quadrilateral OQDM, we have 1, 2, 3 right angles. Okay? Here in quadrilateral OQDM, we have 3 right angles. The sum of 3 right angles is 90 times 3, that is 270 degrees. plus the size of the fourth angle, that is actually angle OQM. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we found out that the missing angle OQM equals to 360 degrees minus 270 degrees, it is 90 degrees. Okay, this angle, the missing angle, equals to 90 degrees. So actually we found out that in quadrilateral OQDM we have four right angles. And any quadrilateral that has four right angles must be at least a rectangle, so we will relate to quadrilateral OQDM as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, OQ equals to DM. OQ equals to DM. According to the rule that the opposite sides of a rectangle are equal to each other, in rectangle OQDM, OQ equals to DM. But we have already found out that OQ equals to small r. We can write here that OQ equals to small r, and from this equation r equals to OQ equals to dm, we derive that dm is also equals to small r. Here, dm is also equals to small r, that is the radius of the small circle. Then we found out the length of line segment PM. What is the length of line segment PM? The length of line segment PM, it is very easy to see from the drawing that the length of line segment PM, here, the length of line segment PM equals to dm minus dp. Again, dm minus dp equals to pm. Okay, here pm equals to dm minus dp. dm equals to small r. According to what we just right now found out, dm equals to small r. This is the radius of the small circle, and we have already found out that dp equals to 7/8. So in conclusion, we found out that pm equals to small r minus 7/8. Okay. Then here, at this point, we have, this is a touching point between the big circle and the small circle. We define this as point S. It is actually also the point of tendency, or the point of contact of the big circle with the small circle. And it is also defined as the launch point of those two circles, the small circle and the big circle. And this is, in this drawing, we have an internal launch point. Why? Because those two circles, the small circle is touching the big circle at point S internally. Why? Because of the fact that the small circle is located inside the big circle, it is defined as internal launch point. So in this drawing, we have the situation of internal launch point that is occurring at point S. Point S is the internal launch point of those two circles. Okay? Then I presented to you rule number 2. According to rule number 2, if two circles have an internal launch between them, then the straight line that connects their centers passes through the launch point. So here, what is the meaning of rule number 2? The meaning of rule number 2 is that if, first of all, we are talking about a launch point, and I've already explained to you that in this drawing we have a launch point. Why? Those two circles are touching each other internally at point S. So in this case, according to rule number 2, the centers, the P is the center of the big circle, Q is the center of the small circle, and the straight line that connects the two centers together is PQ. And according to rule number 2, this straight line PQ, passes through point S. The straight line PQ passes through the launch point, that is point S. Again, according to rule number 2, the straight line PQ the straight line that connects the two centers together passes through the launch point that is actually point S. So we can derive from rule number 2 that points P, Q, and S, they are all located on the same straight line. Because this is actually the meaning of rule number 2. That points P, Q, and S, they are all located on the same straight line. Okay, according to rule number 2, we will derive from rule number 2 that in our drawing, points P, Q, and S, they are all located on the same straight line. Or we can say, we can express it as that line segment PQS, the red line segment PQS is a straight line. Again, the red line segment PQS is one straight line. Okay? Then what is the length of QS? Q is the center of the small circle. S is a point of the small circle itself. This is exactly the definition of a radius. That is to say, QS is the radius of the small circle that is equal to small r. Okay? And what is the definition of line segment PS? P is the center of the big circle. S is a point of the big circle itself. This is exactly the definition of a radius. That is to say, PS is the radius of the big circle that is equal to QR. That is equal to big R is capital R according to our definition. So PS equals to capital R and QS equals to small r. Okay? But according to what we already found out, capital R equals to 25/8. So in conclusion, we found out that PS equals to capital R, that is equal to 25/8. And what is the length of line segment PQ? From the drawing it is very easy to see that PQ equals to PS minus QS. Again, PS minus QS equals to PQ. I'll repeat again. PQ equals to PS minus QS. We have already found out that PS equals to capital R. Here. QS equals to small r. So in conclusion, we found out that PQ equals to capital R minus small r. But capital R equals to 25/8, so we can substitute capital R by 25/8. So in conclusion, we found out that PQ equals to 25/8 minus R units. So we can write here that PQ equals to 25/8 minus small r. We have already found out that PM equals to small r minus 7/8, and here QM equals to small r. So here we actually copied the right green triangle QPM in a new page, and we implemented the Pythagoras theorem on this green right triangle QPM. This is the right triangle QPM that I copied from the original drawing. We know that PQ equals to 25/8 minus small r, PM equals to small r minus 7/8, and QM equals to small r. So according to the Pythagoras theorem, PT is a relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PQ, so the square of the hypotenuse is PQ squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to QM squared plus PM squared. Okay, in conclusion, I found out that according to the Pythagoras theorem, PQ squared equals to MQ to QM squared plus PM squared. PQ equals to 25/8 minus R, so PQ squared equals to 25/8 minus R squared. QM equals to R, so QM squared equals to R squared. PM equals to R minus 7/8, so PM squared equals to R minus 7/8 squared. Here we open the brackets on both sides of the equation number 1. 25/8 minus R squared equals to 25/8 squared, that is 625/64 plus R squared, minus 2 times 25/8 times R. And it is equal to R squared plus R minus 7/8 squared equals to R squared plus 7/8 squared, that is 49/64 minus 2 times R times 7/8. So here we have R squared on both sides of the equation, so R squared will get cancelled. And here we have the expression of minus 2 times 25r over 8. We divided both the numerator and the denominator of this expression by 2. So minus 2 over 2 is minus 1, so 2 will get cancelled. And we left only with minus 25r in the numerator, and in the denominator we have 8 over 2, that is 4. So in conclusion, this expression equals to, after we divide it by 2, equals to minus 25r over 4. And it is equal to r squared plus 49 over 64. And this expression, we have this expression, it is equal to minus 2r times 7/8. We divided both the numerator and the denominator of this expression by 2. 2 minus 2 over 2 is 1. So, therefore, in the numerator we have in total minus 7r, and in the denominator we have 8 over 2, that is 4. So in conclusion, this expression, minus 2r times 7 over 8, equals, after we divide it by 2, it is equal to minus 7r over 4. Here we multiplied this equation number 1, by 64. So 625 times 64 over 64 equals to 625. Here we have minus 25r over 4 times 64. It is actually minus 64 over 4 is minus 16. So it is minus 16 times 25r. So in conclusion, this expression, after we multiply it by 64, equals to minus 16 times 25r. And it is equal to r squared times 64 equals to 64r squared. And here we have 49 times 64 over 64 equals to 49. And here we have minus 7r over 4 times 64. It is actually minus 64 over 4, that is minus 16, times 7r. So in conclusion, this expression equals to minus 16 times 7r after we multiply it by 64. Okay? So here we have minus 16 times 25r equals to minus 400r. So in this side of the equation we have 625 minus 400r. Okay, and here we have minus 16 times 7r equals to minus 112r. So in this side of the equation we have 64r squared plus 49 minus 112r. Okay, here we added 400r to this equation, equation number 1. So in this side of the equation we have 625, 400r minus 400r equals to 0. So we left only with 625 on this side of the equation number 1. In the other side of the equation number 1 we have 64r squared plus 49, and we have here 400r minus 112r. 400r minus 112r equals to plus 288r. Okay? So in conclusion, found out that according to equation number 1, 625 equals to 64r squared plus 49 plus 288r. Here we subtracted 625 from this equation, equation number 1. So 625 minus 625 is 0. Here we have 64r squared, and here we have plus 288r. And here we have 49 minus 625, it is equal to minus 576. So in conclusion, we found out that according to equation number 1, 0 equals to 64r squared plus 288r minus 576. Here we divided this equation, equation number 1, by 32. And 64 over 32 is 2, so in total this expression equals to 2r squared. 288 over 32 equals to 9r. 288r over 32 equals to 9r. And minus 576 over 32 equals to minus 18. So in conclusion, we got the quadratic equation according to equation number 1. 2r squared plus 9r minus 18 equals to 0. In this quadratic equation, the coefficient a equals to 2, the coefficient b equals to 9, and the coefficient c equals to minus 18, and the variable that we are looking for in this quadratic equation is r, so x equals to r. And the general formula for solving out a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, the variable that we are looking for is r. So x equals to r. So we substitute x by r, and we get that r equals to minus b, b equals to 9, so minus b is minus 9, plus minus square root of b squared. B equals to 9, so b squared is 9 squared, that is 81, minus 4 times a is 2. And times c is minus 18. So it is minus 4 times 2 times minus 18 over 2a. A equals to 2, so 2 times 2 is 4. So here r equals to minus 9 plus minus 81, and minus 4 times 2 is minus 18. Minus 18 times minus 4 times 2 is 8, and 8 times minus 18 is plus 144. So in conclusion, inside the root we left only with 81 plus 144. And according to this equation, r equals to minus 9 plus minus square root of 81 plus 144 over 4. 81 plus 144 equals to 225, so we get that r equals to minus 9 plus minus square root of 225 over 4. And the square root of 225 is 15. So we found out in conclusion that r equals to minus 9 plus the square root of 225 is 15 over 4. Okay, so here we will have two solutions that are possible for r. The first solution for r is r equals to minus 9 minus 15 over 4. Minus 9 minus 15 is minus 24, and minus 24 over 4 is minus 6. So we found out that the radius of the small circle r equals to minus 6, that is a negative number. But because of the fact that r is the length of the radius of the small circle, so r is the length, it must be a positive number. R is the length, and as a length, it must be a positive number. It can never be equal to minus 6, that is a negative number. So we cancel the solution, and we left only with the second solution, that r equals to minus 9 plus 15 over 4. Minus 9 plus 15 is 6, so r equals to 6 over 4. We divided both the numerator and the denominator of 6 over 4 by 2. 6 over 2 is 3, and 4 over 2 is 2. So in conclusion, we found out that r, the radius of the small circle, equals to either 3 halves units, or in terms of numbers, it is equal to 1.5 units. And repeat again, the radius of this small circle equals r equals to either 3 halves units, or in terms of numbers, it is equal to 1.5 units. Okay, thank you very much.